Oh, hello, welcome to my video cast. This is Foresight with Evelyn Morales. Today I have a very special guest, retired astronaut Garrett Reisman. Garrett was selected to be a NASA astronaut in 1998. He is a veteran of three space shuttle flights. He went up in 2008, and then you spent what is it, 95 days in space.
So 95, not that I'm counting or anything, but yes, 95.
Yeah, 95 days in the space station. Then you came back down, and then you went back into another mission in 2010 on the space shuttle Atlantis. And in there, and during that time, you performed three spacewalks, which obviously I remember because I was there helping the train with virtual reality. And you also did the operations with the space shuttle and the space robotic arm. I'm sorry, and you were the flight engineer for that mission. You also were part of. Garrett was also part of the NEMO, which is a analog training underwater, and you went and spent also about 2 weeks underwater. That was incredible too. Garrett also retired from NASA in 2011, and he went to join SpaceX as the director of space operations. And after that, of course, he didn't finish there. He went on to retire from SpaceX.
Yeah, I'm not finished yet. Still working.
And
I got bills to pay, Evelyn. I got a mortgage. It's not easy.
So you went on to become a professor at the USC, University of Southern California, right?
Right.
And you became a professor for astronautic engineering, and you have been there doing that since 2018. So I just want to welcome Garrett to my channel, and welcome to this wonderful conversation. Thank you for accepting this. And again, great to see you.
Great to see you too, Evelyn. Although I'm a little disappointed to hear I'm number 10, apparently. I'm the 10th astronaut you've had on the program. I want to know why I was not number 1. Who was number 1?
Oh, I can't remember right now. There has been so many.
Oh, you're making it worse.
Doug. He was the first one.
Doug Wheelock?
Doug Wheelock.
Wheels. Really? Wheels? You picked him instead of me?
Wheels.
I'm a little hurt, Evelyn. I gotta tell you.
Well, you were very busy then. So it was for the SpaceX Demo 2 flight was going on actually.
Wow.
I did the first one.
That was a busy time. Yeah. That's all right. Fair. That's a good excuse.
Yes. So great to see you. Great to have you in this program. And again, I wanted to now talk to you going back, several years ago as you were training with us in the virtual reality lab. And I'm sure that I heard all the comments from many of you saying, wow, we're going to the VR lab, we're going to train in this sci-fi, world. How did that experience actually going through that training, which was probably a little unique at the time, right? If you go back, that many years, how did that kind of help you or to visualize the space and possibly some of the creativity that came after that?
I don't know, that's all right.
Well, thank you. Wonderful. Thank you. Okay, we're done.
Sorry, I had to get you back for making me number 10.
I knew we were going to do this.
It's going to be a long interview, Evelyn. I hope you're ready. Yes. So, no, seriously, it was really ahead of its time, because like now we take VR for granted. You can get an Oculus headset, and you can, my 9-year-old kid has done some VR stuff, and it's kind of VR and augmented reality are becoming more and more common. But at the time we were doing it, it was unheard of. It was really cutting edge and really first time, and it was tremendously beneficial. So the most beneficial use of the VR when I was at NASA training this fly in space by far and away was for orchestrating combined spacewalk and robotics activities. So we would, you know, at my last mission, we were doing spacewalks where sometimes I'd be outside and I'd be in the suit, and we'd be installing, for example, we had batteries that were installing on the truss that stored energy coming off the solar arrays, and those batteries were stored on a giant pallet that one of my crewmates Piers was holding with a big robotic arm, and he was moving that thing around. I had to give him directions like move it to the left. And when you're in space, it's like, well, what does that mean to the left? Now, where is left? Where is up? Move it up. What is up? You know, there's no gravity, right? So it's like you got to get your story straight. And so that's why the VR lab was so useful, because we can go and get into that virtual environment and then say, well, what does up mean? Well, okay, let's agree that up means towards the top of the space station. Okay, so I'm going to say move it up, and you move it that way. And then he can move it, you know, he actually can move the controls, and to him it felt very, very flight-like, that he was manipulating the arm and the pallet, and he could see it move on screens that simulated what his cameras were going to actually look like, very, very closely to the real thing. And at the same time, I would be in the VR headset, and I would look over and I would see it move, and I would confirm, yes, that's the correct direction, or no, that's not actually what I meant by up. And we can get it all worked out. And that was tremendously helpful. There was no other facility really that could put it all together like that. We could do it in piecemeal. We can do training on the robotics by itself, and we could do training in a giant swimming pool for the spacewalk by itself. But as far as choreographing and putting it all together, there was nothing that could come close to what the VR lab could do for us. And we got to these really complicated spacewalks and robotics activities, like building the space station or working on the Hubble. Then it really, really was important. So yeah, it was, and plus it was a lot of fun because you guys were great. You know, every time we would go over to the VR lab, it was always, whenever that showed up on the schedule, it was a highlight, because you knew, in addition to getting great training, we were going to have a lot of fun.
Yeah.
And, everybody, it was
Yeah.
a special group. It was a special group of people that worked in that with you, and obviously you being one of them. But it was a special group. You had a whole team of people that were fun, good people that did excellent work, but at the same time knew how to have fun along the way. And of course there were lots of things that we did that were very memorable. So yes.
Well, and you know, we were trying to push the boundaries of you know, innovation in terms of, there was a lot of stuff going on internally, obviously, you know, that we have to overcome in order to make that a viable, positive training, because it wasn't easy by no means. So and that's why you know, when we talk about commercializing and having the opportunity for this agility in terms of, you know, the engineering and development is important, so that we can really innovate, and the freedom that was giving to our team, you know, that you probably found as you went out, right, from NASA, but the freedom to our team, what we had, that had all to do with management too, allow us to go beyond, to generate and to push that technology as much as we could, and internally, because there wasn't many years throughout that we didn't have the helmet available, you know, commercially. It was all built internally.
Right.
So
No, it was really interesting in that and it wasn't only when I left NASA. It was very obvious when I was still in NASA, was that the VR lab was a unique place where you had the freedom to innovate. And frankly, that was not the case throughout the vast majority of NASA at the time. It was really hard to do things rapidly, to do kind of rapid prototyping or really innovate with new technologies. And because of the risk aversion that came from the accidents, you know, that NASA, after Apollo 1 and Challenger and then Columbia, got very risk averse, you know, in an abundance of caution to look. I lived through Columbia, and I know you were there too, and it was very, very difficult. And of course, if you live through a tragedy like that, you never ever want that to happen again. But at the same time, you know, our reaction was to just, let's not take any risk. Let's not change anything for fear of an unintended consequence of a change. And so it got very, very difficult to do anything innovative. And I was working around that time on a project called the Cockpit Avionics Upgrade, where we're trying to put new displays into the shuttle. And what we were allowed to do was really quite limited in even like basic things. I'll give you a quick example. So I told I told the story to Chuck Yeager once. I had lunch with Chuck Yeager, and he said, "You know the problem with you astronauts today," because he's a very crotchety old guy now. He said, "The problem with you astronauts today is you're not down there at the Cape watching your hardware. You know, when I flew the X-1 and broke that sound barrier, nobody touched a rivet on that airplane without either my eyes or my crew chief's eyes on it. You know." And I'm like, well, let me tell you a story. Not only can I like go down and like turn a wrench on the space shuttle, but I was trying. My job was actually to create new checklists. We were creating a whole new cockpit that was going to be a glass cockpit inside the shuttle. And so we had to upgrade and redo all of our checklists, all of our flight data files, official name, but it's basically the books of procedures that we use to fly the thing. And my first thought was, well, let's do something innovative here. We're making a new cockpit, 21st century. How about we do this electronically? Why don't we have tablets that we can have on our knee, and then we can have an RF or Wi-Fi link to the telemetry from the vehicle, which was all doable. You know, nothing in the laws of physics prevent you from doing that. And then we could have a smart procedure. So instead of like having an engine fail procedure, and they say, well, if step 1, is it the center engine? If not, go to step 5. Is it the left engine? If not, go to step 8. Instead of having to do all that, it could be smart and say, oh, it's the left engine. I see that that's the one that's having the problem. Here's the procedure for the left engine. Boom, you know, and it could be smart. And they said, no, we can't do that. That's way, there could be, you make a mistake. You know, we don't have the budget. We can't make that. It'd be too expensive to get that certified. No way. So no. Then my next idea was, well, how about we do something really innovative here and fancy? Let's like use color, because all of our procedures are in black and white. So why don't you like use color? Then we can make the emergency stuff red. We can make the cautions yellow. You know, it'd be great. And they're like, no. Say, because so some of the people might be colorblind. I'm like, you test all of us. You know, we're not colorblind. The colors, you know, we'll be okay. And then like, well, we can't buy color printers. We have all these black and white printers, and it costs too much money to get the color. And it was like, and so at the end of the day, the one thing I changed that was significant was sometimes in the procedures, it'll say like set temp -20. And it kind of looks like -20 when they're really trying to tell you to set the temperature that +20. So instead of a dash, can we make it an arrow? So set temp -20. So I know it's not -20. Yes, that was my innovation. Okay. And I told that story to Chuck Yeager after that whole story. He looked at me and he goes, "You sorry bastard." and he understood. And it was that kind of frustration throughout. It was that hard to innovate throughout the rest of the organization. But the VR lab was shielded from a lot of that, and in a very clever way, because the VR lab was careful never to put themselves or their products in like the critical path, where if there was an error in it, there would be nothing to stop you from a catastrophe, right? And that was smart. That allowed you to like make innovative changes and do really advanced things, because we could say, well, you know, yeah, we're going to have this tool, but it's not the primary tool. We're going to really look at this camera. We're not really going to look exclusively, you know.
Even though you were looking at it for
we did.
awareness for robotics. Yeah, that's true. That's true. That's what made it, you know, to get away from that path, you know, of being kicked out.
Right.
Because and also, I mean, we continue to integrate new things all the time. I mean, that was very agile to anytime there was something new, we will, you know, improve it. And,
rapidly, you very quickly, you incorporated new technologies, you incorporated new capabilities, upgraded software,
new colors,
new colors,
color coded stuff.
You can do all that kind of thing.
Yeah.
And that the VR lab was this little isolated pocket of ingenuity and innovation in NASA that did remind me a lot of, like, it functioned a lot like SpaceX functioned. When I got to SpaceX, there was a lot of similarities there in the way things operated. So that was pretty cool.
And that was, you know, I was going to talk to you about when it became, you know, apparent after you did your last flight in 2010, you know, okay, what are you going to do? You know, this is, you were looking to what were your next step. And I started working with some of the stuff from SpaceX in, I think it was 2009, a little bit there. We started to get some of the models and the simulations, but it was very early in the beginning and people were hesitant, right, to will this work? And then it come, 2011, you left and you went to SpaceX. I mean, how did you feel, going through that transition, and knowing that you were going to go to something very agile, very demanding in some area.
Well, the decision to leave, because it was tough. It was really tough to make that decision to go, because I'll be honest, being an astronaut was like the coolest gig ever. I was like, you get to fly around in jets and stuff, and that's like work. It was like so much fun. It was really a great, great deal. And so giving up on that voluntarily was not easy, but the couple things that kind of led me to make that decision was, one, the shuttle program was coming to an end, so I knew the flight opportunities were going to be less frequent, and it was going to be a long wait. I came back from my mission in 2010, and I was going to have to get in the back of the line and wait for my next turn. And then also there was that frustration with wanting to do innovative things, and that story I told you, it was kind of humorous, but it was real. And so and then when I saw this other company, SpaceX, and this really happened when we were getting ready for my last flight on Atlantis. We went down to Florida and we were supposed to roll Atlantis to the pad. And I know this should come as a huge shock and surprise, but it rained in Florida in the summer and the ground was wet. Who saw that coming, right? But it was, and so we had this delay, and they said, "What do you want to do?" And my crew said, "Well, we saw, this company, SpaceX, starting to create this new launch pad over here at Cape Canaveral Air Force Station. Can we go have a look and meet those guys?" And they're like, "Sure." So we drove over there and they welcomed us in, and our eyes were really open. We were shocked by like how fast things were coming together, how innovative they were, that all this stuff really impressed us. And then when I got back from that mission, I called an old friend, former astronaut Ken Barrosox, who was at SpaceX. And I said, "Look, I really liked what I saw in Florida. I would like to check out headquarters and the manufacturing facilities in California." And he invited me out, gave me a tour, and he did everything he could to talk me out of coming over and working at SpaceX, because he wanted to make sure I was doing it for the right reasons. And despite his best efforts, I ended up having a job interview with Elon and asking for a job, and he said yes, and then I started. So it was, I kind of knew then, I was still young enough that I was ready to launch a different phase of my career, and instead of kind of staying at NASA and flying again. And in retrospect, it was a hard decision, but I think it was the right decision. I'm glad, and the memories I had and the things that happened at SpaceX are experiences that are really, really valuable, and I'm glad I did it.
No, and you know what? I mean, definitely was the right time and the right thing to do, because I remember several astronauts actually asking, coming to the lab, for example, looking for that innovation, that opportunity for innovation. And since you said it was very here and there, it wasn't all throughout the organization. It was very seldom. And the need to do that, especially what you're saying, you were gonna have to wait for your flight, for the next flight, right? So it was definitely, a good decision, and difficult, I'm sure, because it's very competitive, and the things that you have to probably overcome being in that kind of environment, especially early on where you're trying to prove all that technology. let's rescue boosters, right, and fly them back to a barge in the middle of the ocean. I mean, obviously that's impressive, but you were part of that. It's incredible. I mean, I'm so proud of you, and I never forget when I will tell you, "Garrett, come on, please, we need to fly again from the US."
Yeah, and boy, it just this past summer when we did launch Bob and Doug on the SpaceX rocket and finally fly people on our vehicle. At that point, I had left SpaceX and I was working at where I am now at USC as a professor. But it still felt great, because it was there was still 7 years I put into helping make that happen and to see it actually come true. There were times, you know, at SpaceX where, you know, when we had successes at SpaceX, it was so exciting. Some of the stuff, like the first time I saw live us land that first stage booster on and bring it back to the launch, near the launch pad, and land it and recover it. Even though I had absolutely nothing to do with that other than maybe securing some of the funding that helped make it possible, I really had no involvement with the engineering and solving those technical problems. But standing there with the team and just being a part of the team, even in a very peripheral sense, was so exciting and satisfying. I mean, I would say it was one of the most exciting moments of my career. And I've done 3 spacewalks. Okay, so I mean, it was like super. It felt great. And like also like the first time we flew the Falcon Heavy, the first flight of the new Falcon 9. Those moments are really, you know, imprinted on my mind as really powerful, exciting events. And that's not to say that it was all like that, you know. And I think it was so. It felt so wonderful because it was so hard, you know. Like JFK said, we're gonna go to the moon and do these other things, not because they're easy, but because they're hard.
Always.
By the way, my son has thrown that in my face. He said, "I'm going to clean up my room, Dad, not because it is easy, but because it is hard." Like, okay.
Oh, there you go. There you go. No, you know,
But it's true.
that's what happened. I mean, when things come easy, you don't appreciate them as much as when they are difficult to do or difficult to get, and that you goes for many things in life, right? But so now, so comparing, right, that type of you know, what you saw in a SpaceX, for example, and you know, we take a SpaceX because you were there, but I'm sure, and I know many of the new companies in the commercial space now, they're doing a lot of things that are innovating new and you know, how those processes and what you were seeing, how they were aiming to solve the problems were different to what you were coming from NASA, right? And 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 you know, I want you to talk a little bit about that, and because that is really aiming into how can we help the young engineers to be part of that now, right? And probably how can we help the old management to being able to kind of help mentor, whatever, you know, how can we?
Yeah. Well, it was, and I think you know, your experience in the VR lab was different, but I think, you know, one of the reasons or the keys to being able to do a lot of these great things, like being able to recover first stages and land them on ships in the middle of the sea and fly the Falcon Heavy, you know, with and recover all 3 the 2 first stage side boosters in the center core, and all that cool stuff, and all the stuff going on right now with Starship. One of the biggest differences between SpaceX and NASA that I observed was decision speed. You know, we would make a decision at SpaceX in a week or even a day or even one meeting that we would sit on and contemplate for a long time, you know, maybe a year at NASA, a similar decision. And this is, I don't mean to bash NASA, and NASA was that way for a very good reason, which is that the reason it worked for SpaceX, but it really couldn't work for NASA, was SpaceX enjoyed the luxury of having a tremendous amount of agility. And a lot of that came from our vertical integration. So we did a lot of our stuff in-house. We even made our own spacesuits. So a lot of the stuff that we normally think you would subcontract out and hire a supplier to do, we did it all ourselves. So what that allowed us to do was that gave us a tremendous amount of agility, such that if we decided, if we make it, because the problem with making rapid decisions is you could easily make a wrong decision. And when you make a wrong decision in the space business, a human spaceflight business, that could be really bad, right? But if you make that decision and then go out and build it and test it, and find out that you made the wrong decision, you find that out very quickly. Like if you decided, and then if you need to make a change, if you have the agility to pivot and turn on a dime and change direction immediately, then you can actually converge on the correct engineering design very quickly and much more efficiently. And SpaceX could do that because, like, if we realize we made a mistake, you know what, these 3 parachutes aren't really working out. We thought it would be sufficient, but 4 would be great. It'd be better to have 4. We can just say, hey, throw another parachute on that thing, and boom, it happens very quickly. In a big NASA project, with a traditional aerospace contractor that has tiers of suppliers and subcontractors, and there's the requirements are all laid out and flown down to down to the very granular level, and all those documents are locked in stone, and lawyers have negotiated contract agreements, and you got to tear all that up to change it to add another parachute. That's expensive and hard. So
10 years.
It take years. So you better get that right the first time, and that's why they can't afford to make quick decisions. And the consequence of a wrong decision is so much higher from a cost and schedule perspective at NASA or at Boeing or Lockheed or any of these big places than it was at SpaceX. SpaceX could make a decision, find out it was wrong, very quickly change without having to deal with all that overhead. So I think that if people ask me what's the biggest difference that I noticed between SpaceX and NASA or the rest of the aerospace industry, and I say decision speed.
That's probably the biggest. And also, I think I see it from the business side of it is the vertical. The vertical business model. Basically, you have to go through 5-6 management to make a decision. By then, like I say, it's in a year pass or a year and a half to make a decision. And if it's a more flat organization with heavy lifting, and I think the part of it is making sure that you're accounting for things, right? Or making sure you're rechecking, but how much can you do of that? If you have good equipped, good engineers, you're going to be rechecking, and so there are ways to do that if you have a flatter organization, and I think that's what SpaceX is more like. So no, that's great. And so in academia now that you move from SpaceX and you do all this wonderful.
Yeah, I'm thinking I should put on my, hold on.
Yeah, you go and put your.
Change it. I got my professor tweed sport coat here with the elbow patches and everything. No, I don't.
No, we don't need that.
But yeah, so things have changed.
Professor, so now
I'm a professor now. Yeah.
It's amazing. You have.
So I got all these books.
Oh my God! Yeah, pretending.
No, I read this one, the gas dynamics. It's fascinating. Chapter 2 is just a page turner. I can't recommend it enough. It's awesome.
So you went now to become a professor, in academia. And amazing. So what are you teaching the students apart from, okay, I know your theory and everything, but what are you teaching me about life through this engineering world and how to, because it's more agile, it's different. How do they go? And of course, 20 years ago, the options and opportunities to get into this area of space exploration was more limited. And now they're having more opportunities. So what are you telling them?
Yeah, so first of all, the courses I'm teaching at USC all have to do with engineering for human spaceflight. They're all related to human spaceflight. So I teach 3 courses. I have one, and they're all master's courses. They're all my students are either getting their master's or are going to go on to their PhD. So they're either PhD or master's students. And the courses have to do with specific topics. And really the way I came up with the curriculum was based on my experiences at SpaceX. So when I was director of space operations, I hired people to do different jobs. And there's some jobs where it was really easy to hire somebody. If we needed somebody to write flight software that can code in C++, we can get any graduate from one of the top computer science departments and plug them right in, and they would, on day one, they'd be able to help. If we needed somebody to do finite element modeling structures or aerodynamics, CFD stuff, no problem. We can go find those people, and boom, on day one, they know what to do. But if you needed somebody to make a spacesuit, or somebody to come up with a life, or even somebody to design a system that has a human in the control loop, what do you do with this soft pink component of the system? How do you take advantage of what they have to offer? How do you make sure that they don't make things worse. How do you design interfaces so that they can contribute to the operation of the vehicle? Those were things that like nobody was taught in undergrad. Everybody came out of and nobody had a clue, and all that stuff they had to learn on the job. So my intent was to create a series of academic courses so that graduates from my program and that take my courses could go in and work for the old Garrett at SpaceX, you know, go in a time machine, go back in time and work for me when I was director of operations, and be able to contribute on day one without having to learn all this stuff for the first time. So the courses I teach I have an introductory course to human spaceflight plus operations. And there's some systems engineering aspect of that as well. And then I have a course on human factors that goes into all the how do you integrate the human into the control loop of a spacecraft, and how do you do what's most common today, which is human control of highly automated systems. So we talk about that. And then I have a third course that's all about the hazards of the space environment. How do you protect human beings from radiation, from micrometeorites, from depressurization, and all the other things that can harm you? And then how do you design a life support system and a spacesuit to sustain human life in space? So those are the three courses. And along the way, you know, yeah, I teach them a lot of engineering fundamentals and techniques and knowledge. But there's also, you know, one of the things I think you're hinting at there with your question is about just how to, you know, I've had so many different experiences over the course of my life and my career, my education, that I do try to share that. And one of the things that I do outside of my courses, and sometimes it creeps in, is help them deal with a lot of the anxiety and stress. I find that students these days, and by the way, I'll have to come back and do a whole nother program on this because this is much more than I can do. And
Yeah.
I think we're out of time right now. It's so
Oh,
I need another half hour to cover this adequately, but I do try to help them in dealing with a lot of the expectations that they have. And I find that students these days are in a very different environment than it was like when I was a student, either undergraduate or graduate in university. And I blame social media for a lot of this, but there's this outsized
a lot of
expectations.
distraction, you mean? Distraction?
No, it's more kind of a, they're too connected in the sense that they feel like they have to live up to a certain ideal or compete, or that, you know, they think that the stuff that they're seeing on Instagram and Facebook is real, you know, and they feel like, well, I mean, this really came about when I went back to my alma mater, which is the University of Pennsylvania, and I won an award for student leadership like 25 years ago. And I went back, and they do a neat thing where they have the person that won it and is back for their 25th reunion hand the award to the kid that wins it that year, right? So I was handing this award over, and they were listing the accomplishments of the award winners, and it was ridiculous. It was like, you know, they were like captains of the football team. They had a perfect 4.0 GPA, and they created some app that provided clean drinking water through the continent of Africa. I mean, I'm exaggerating a little bit, but the stuff was like insane. And the four of us that won the award 25 years ago all looked at each other and, interestingly, had the same exact reaction, which is like, what is wrong with these kids? You know, if they're doing all this, they got to be so stressed out. And when are they having fun? When are they going to parties? You know, when are they going to football games? You know, what kind of experience? What is their life like if this is considered the standard of excellence that they all have to compete? And the problem with social media is they know what the guy did last year. Okay. When I was there, I had no idea what the guy did the year before me that won. So I did the best I could, and I guess that was good enough.
Wow.
But if you know what the guy did last year, then you feel like, well, I got to do a little bit better. And then guess what? The guy that comes the year after you has to do a little better than that. And it becomes this ever escalating cycle that leads to a situation where the kids are just working their butts off, and the what they consider to be the definition of success is too high. So Anyway, like I said, we need another
No, this is
hour to
very
do with this. But
interesting just because, you know, I'm in academia too, and education, and these are important problems though, even though we're getting more serious here, but these are very, very important problems because, I mean, if you look at yourself back, I mean, you had that time to play and look at all the stuff that you've resilient throughout your life were able to obtain, but you were not overly worked when you were a child or younger. You were probably playing, you know, outside. We didn't have that. Neither me. I was playing Lost in Space, so I was playing things outside. And but I was able to then to put the time and that effort and that extra as I was getting older. And it's true. What are we going to expect from the kids to do when they get older? I mean, they're going to be stressed out. And there is no need to do that.
And it takes a real toll on mental health, and we're seeing that throughout campuses. It's becoming more of an issue, and it doesn't end. It's not just the college experience that continues in their internships, and it continues in their professional career once they leave. This is really a societal change that affects. I mean, it even starts, you know. The arms race begins even in elementary school in some cases. So it's something that as a society, we've gotten to this place. And I think that we need to take a careful look at what we've created and reevaluate if this is really the best thing.
That's way. And well, in COVID-19 has actually pushed this even to the next level, because now we're, you know, and, you know, even the kids, I mean, now they can't socialize as they used to imagine that.
Yeah, it's placed all new restrictions on their life. So yeah, it's not easy.
It's not easy.
And now as a parent, you know, I'm especially concerned about these things. So it changes everything too.
Definitely, but I'm glad that you know this and you can be on top. But many parents don't. That's the difference. See, you know. But well, the last thing that I just want to talk to you real quick, because I know this is something that you have done a lot, is help the entertainment business. You have actually and done all this fun, you know, and be part of these consulting teams for these shows, and I'm sure that you have enjoyed that as much as being at NASA.
Yeah, you know, this happens when you move to LA. They once you buy a house, they automatically give you an agent, and they get you. You know, you can't help but go Hollywood. So yeah, I did. It's been fun. I've worked on some film production. I was a technical advisor for the Brad Pitt movie Ad Astra. I got to teach him how to fly a spaceship, and that was really fun. He's actually a really great guy. And then I've been working for a couple of years now on the show For All Mankind on Apple TV, and that's a show that was created by Ron Moore, the guy that did Battlestar Galactica, the reboot, and Outlander, and being able to work on, and I've been actually much more involved in that production than the movie, and it's been super fun. I gotta tell you, it's like the thing I didn't expect when I got this astronaut gig was that it would open up all kinds of doors that I would never in a million years. Like, I'm sitting in the writer's room for this TV show, helping come up with story ideas, right? I'm an engineer. What the heck am I doing in there? You know what it's like? It's like when you go and you pay a bunch of money and you go to fantasy baseball camp and you like take batting practice with the Astros or something, you know, and they humor you because you paid a lot of money. And so like, oh, nice swing. And, you know, and they make you feel like you belong when you really have no business being there whatsoever. It's kind of like that, you know, and I keep expecting them to tap me on the show, say, okay, your $1's up, time to leave, get out of here. But it's super fun. And it's neat. It's incredibly, I feel incredibly privileged to participate with such a high level of talent in an industry that I otherwise never would have participated in, and get that experience too. It's been really cool working with the stunt team, working with the art department, the set designers. It's been really cool.
And you believe, I mean, you believe that what we create in movies, right? Even though it's fantasy, sci-fi, and some of that is things that we are aiming to even do, really, as an engineer. To really.
No, it's very symbiotic. You know, before you can design something as an engineer, either you or somebody else has to imagine it. And a lot of times our inspiration for engineering design comes from artistic depictions in film, TV, or literature. And a classic example is if one of the best science fiction movies of all time is 2001: A Space Odyssey. And if you watch that movie, you'll see the crew of that ship using tablets. And I think Steve Jobs was on the record saying that, yeah, that's where he got the idea for the iPad. So it is, you know, it really is an interesting interplay. And at the same time, the artists and writers that are creating these fictional depictions are inspired by what they see in real space exploration. So, you know, talking to Ron Moore, he was inspired by Apollo, and that's why he went off and wrote for Star Trek. You know, because he wasn't only inspired by past science fiction, he was inspired by science reality and our accomplishments at NASA. So there's definitely a really interesting interplay that we go back and forth.
Well, I hope that people now with the COVID-19 and kind of stopping a little bit, right? Like stop time for a minute. When you look at your everyday life, you're going to find things that you can enhance and improve, and where whatever you know, you can actually, you know, improve your surroundings. And that's how innovation happens. So if you stop really, and that's something that I learned right through our time in the VR lab, is many times we just stop what we were doing and kind of sit down and look at the simplicity of some of the system, the things that we were doing. And that's when the inspiration for something new to make it better. You know,
you need that time. You need that time to pause and reflect, and to you know, if you fill your time up just trying to get the next thing done, you never really have that chance to make things better. So yeah, you're right. This is a valuable time in a lot of ways.
Yeah, I hope that the kids do that too.
Yeah.
So anyway, well, Garrett, it has been fantastic talking to you, seeing you again, and you know, discussing about all this. Is incredible career and all the experiences that you have. But I'm so glad to being able to be part of that early career at NASA with you, training and doing all those fun things for spacewalks and robotics. So, but I want to thank you for accepting the invitation to talk to me. And if you
My pleasure.
to the audience.
Evelyn, is the least I can do. I owe you big time for everything you did and all the fun we had in the VR lab. And I'll have to come on the show some other time and we could tell old VR lab stories. But I cherish them, and was really happy that you invited me on the show.
Thank you. Thank you.
Thank you.